Hello, my dear student. I'm Mr. Kitwala from Educators. I will be with you in physics Form 5. So, welcome again to proceed with our discussion on our topic of rotation of a rigid body. For our subtopic, say that axis theorem of rotating bodies. Now, let us proceed with this discussion. The study session for our subtopic as we try to observe here. So before we continue with our discussion here, we are supposed to remember where we ended on the last session. On the last session, we tried to see how the parallel axis theorem can be applicable on our daily life. And we said that this is very important because it is applicable so as to identify the moment of inertia for different geometry, like for the solid cylinder, for the solid sphere, and also for the uniform load. That is what we try to demonstrate, and we obtain some formula related on how we can find the moment of inertia. So for our today's discussion, we are going to look about the second part, which is called the perpendicular axis theorems. We have said that this theorem is categorized into two parts. We have the part one, which is about the parallel axis. I explained that a moment of inertia through any axis equals to the sum of the moment of inertia through the center and the product of the mass times the distance, perpendicular distance from the perpendicular distance through the parallel axis. So, and today we are going to look about the perpendicular axis theory. How can we state the perpendicular axis theory? Because there are so many questions you'll be asked on your examination. Is how can you differentiate the axis, the perpendicular axis theory, and also the parallel axis theory. Now, how can you state the perpendicular theory? So here is our statement related with the perpendicular theorem. And our statement said that the moment of inertia of a planar object about an axis perpendicular to the plane intersected by two perpendicular axes can be determined using the perpendicular axis theory. So we identify the perpendicular axis theory for the aims of knowing the moment of inertia for a planar object about an axis. That is how our statement said here. So our law, how can we state the perpendicular axis theory? That is what we are going to see the way we can state it. So our law said that the moment of inertia of a plane body about an axis perpendicular to its plane is given by the sum of the moment of inertia about any two mutual perpendicular axes in the plane intersect the first axis. Now, imagine we have three axes. The first axis run into the z axis. And also the two axes run perpendicular to each other. It means we have the three axes. One of them lie along to the z axis, and the two lie perpendicular. It means one is vertical and also the second is horizontal. They produce a 90 degree. That is why we say that they are perpendicular, and they produce our law, which is said the perpendicular axis of the perpendicular axis theorem. So the moment of inertia about any axis perpendicular to the plane is given by this one. So we obtain the moment of inertia perpendicular about the axis perpendicular to the plane by taking the sum of the moment of inertia about any mutual perpendicular axis in the plane and axis. Kwamba ili tuweze kupata sasa ile moment of inertia, wanasema tutachukua ile moment of inertia ambayo iko perpendicular lie down along to the z axis, we add by we should take that one which is equal to the sum of the moment of inertia that lie mutual perpendicular to each other. It means tutachukua ile moment of inertia along to the z axis which is equal to the sum of the moment of inertia along to the x axis, then we add by the moment of inertia along to the y axis. This is how our law said. So by using the formula, we can say that the law, if we formulate the law through the symbol, we could get that moment of inertia along D must be equals to the sum of the moment of inertia along to the x-axis. Then we add by the moment of inertia along to the y-axis. But you have to remember that this along the axis, x-axis and also y-axis, they lie mutual perpendicular to each other. They produce the 90 degree so as to form the perpendicular. So we know that the perpendicular, when we talk about the perpendicular, is the 90 degree. Kwamba tunakuwa na straight line mbili lakini zinatengeneza angle ambayo ni sawa na 90. That is what we know about the perpendicular. So unlike the parallel axis theorem, the perpendicular theorem works for the planar two-dimensional and both. As we know that this parallel axis pamoja na perpendicular axis theorem zinakuwa zina works for the two planar for the planet, it means for the two dimension. Hizi zote zinakuwa zina focus kwenye planar pia, au tunaweza kusema kwamba kwenye two dimension ya both two, kwamba haziwezi zika works more than the two dimension. That is what our statement said here. So let us consider a planar boat of mass m rotating about the z axis. Then consider the particle p of mass m at the distance from the center of the planar boat here. So my dear student, now we are going to see to consider the figure. Imagine we have the figure that represent the planar body of the mass m, and that planar body of mass m tried to rotate about the z axis. They rotate along the z axis. Then after there we should consider the particle p, kwamba along the rotation we will have the particle p, and that particle p should involve the mass m kama tutakavyoenda kuangalia kwenye figure yetu. Lakini yule particle ambao ana contain mass m ambao mean placed at the point p atakuwa na distance, atakuwa na some distance ambayo tutaenda kuiona. Distance yetu tutaita ni r kutoka kwenye center of the planar boat, as we have as we are going to see on our figure number 14 for our fourth topic here. So our figure, as we observe here, that we have this figure that represents the planar rigged body with a rotating axis at its center. Kwa tuna hii hapa planar boat ambayo inajaribu kurotate about it is about an axis at its center. Kwa inajaribu kuzunguka. Tunajua kasa kwamba when we talk about the rigged body is an irregular, it means kwamba it doesn't involve the known shape. Inakuwaga na unknown shape. Kwa kama tunavyoona shape yake sasa kwamba this try to rotate about an axis perpendicular to each other along to the z axis. Kwa unaona hii body yetu inapokuwa inazunguka along to the z axis, as we should observe the angular velocity, direction of the angular velocity. Kwa hiyo hapa inakuwa inajaribu kuzunguka about the axis for along to the z axis. So our figure here involve at three axes. We have the horizontal axis ambayo tunaita ni x axis, and also we have the y axis ambayo tunaita ipo kwenye vertical axis, lakini pia tuna hii z axis. Kwenye z axis ni sehemu ambayo rotation ina takes place. Lakini sasa law yetu anasemaje kwamba kwenye sehemu ambayo axis ina takes place, moment of inertia wake ni sawa na sum wa wale mutual perpendicular wa moment of inertia along to the x axis and also the moment of inertia along to the y axis. Also inside for this planar rigged body, we have the particle which containing the mass m. Kwa tuna particle yetu ambayo ina mass m, na pia ile particle imebini placed at a certain point as we try to observe, but the distance from n up to this point of the particles, we could say that this should be the y, and also the distance, horizontal distance, it means from O to n could represent equals to x kwa sababu ipo kwenye x axis. So what we are going to demonstrate here, we are going to see how can we form the formula of the moment of inertia for the perpendicular axis theorem, as we have been obtained into our law, which said that the moment of inertia through the axis must be equal to the moment of inertia through the x-axis we added by the moment of inertia through the y axis.